Good morning, everyone. Um, Today I'm gonna talk more about the vector. And again, we're gonna use this vector in the addition and the decomposition over and over. So make sure you understand this section clearly. And then basically, the coordinating system you have used is called a Cartesian coordinates, where you have in general y-axis and x-axis, right? And then you have a 90 degrees, right? This is a typical, coordinating system you have used. And then now vector, a random vector is basically consists of a two vector addition. So last time we talked about, how you add two vectors, right? So assuming a x vector is a purely horizontal vector, and then a y vector is a vertical vector, and then a vector is the sum of these two vectors. So then you simply add, right, or place second vector, a y vector, at the head of the first vector, right? So then you go this, it's the same as a vector. So basically any random vector, a vector, you can express this vector in terms of sum of one horizontal vector plus one vertical vector. Always, right? So if your a vector is a purely horizontal, then you can say a y component is 0, but you still have a vector, this horizontal a vector equals a x vector plus a 0 vector with times a y vector, right? So you can always express a vector in terms of a horizontal component and it's a vertical component, right? So for example, a vector here, you can express a vector, you know, how many x component you have, 1, 2, 3, right? And then how many y component you have, 2. So you can say a vector is a 3 comma 2, but this doesn't mean the position of a vector is 3 comma 2, which is 3 comma 2 is right here, right? No. What it means, whenever you express a vector in terms of cer- a value comma another value, that means that this is your horizontal component and this is your vertical component. So you move, this much unit horizontally and this much unit vertically. So for example, b vector, you gotta go, starting from here, v vector, you have a -2 and up 2. So your b vector, you can express your b vector -2 comma 2, right? And then, so the thing is now you can, if you have this graphic, and then if, the b vector's component is clearly in a whole number, so you can easily find it. But what if your b vector or a vector, for example, here, it's not, 3 and 2 clearly, it's somewhere here, it's not easy to find it, right? So then you have to decompose your vector using tree. So for example, let's assume you have a vector and then angle is given. So a vector is given, that means the magnitude and then angle is given. So then, in other words, in general, if you have a triangle or vector, you know, last time we talked about in order to describe a vector, you must describe the magnitude, right? So for example, 10 centimeter or 10 unit, and then angle is 30 degrees, right? This is actually how you describe a vector. So if you draw, and then this 30 degrees always from the horizontal positive x-axis, right? So your a vector, length 10, and then angle 30 degrees, right? So basically now you're interested in how you express your A vector in terms of a magnitude R and then angle theta to what? X comma Y. Here X is a AX, here Y is a AY. So in other words, this is a AX, this is a AY. So that simply this question is a mathematical question, is I know hypotenuse of a triangle, and I know the angle of the triangle, one of the angle, because this is a 90 degrees, right, triangle. So you either have this angle or the other angle, right? So then how you find AX, AY, which is the other two lane lengths, right? Except this hypotenuse, right? So then you can simply use what? Sine or cosine function, right? So here sine 30 degrees, or let's assume this is your x, right? And then let's assume this is instead of 10, a. And then now you're looking for B and C. So that means that this is your B. You want to express this one, B, comma, C. So this is now A, right? I change its hypotenuse. Angle is a theta. So I'll change this one, theta, right? So then what is your sine theta and then cosine theta? Sine theta is what? C over A. Cosine theta is a C over B. So if you multiply A both sides, you see C equals A sine theta. B is A cosine theta. So then in other words, B is A cosine theta. C is A sine theta. Right? So then how you remember this one? Because this B is adjacent to this angle, right? And then this C is opposite to the angle, right? So if it's adjacent cosine, opposite sine, right? Adjacent cosine, opposite sine. But let's assume this is a theta 1. Our problem sometimes is because this is a triangle, right? You always have two angles except this hypotenuse. So that means that this is your theta 2, for example, right? So then what is a B and C as a function of theta 2? It's the same. This is A. Again, now B is opposite to theta 2. So it's opposite, so it's sine theta 2. Of course, this is 1, this is 1. And this one is what? Adjacent to theta 2, so it's A cosine theta 2. So it really depends on which angle is given, but you may have a question how these are the same. But now, this is triangle, this angle is 90 degrees, so you can say theta 1 plus theta 2 is always 90 degrees. So that means here, sine theta 1 is a cosine theta 2. That means sine, for example, 30 degrees is a cosine 90 minus 30, which is 60 degrees. So which are the same 1/2, right? This is one of the, trig rules, right? So you can always say the angle, whichever angle you choose, doesn't matter. If you choose this angle, then this line is adjacent, this line is opposite. If you choose this angle, this is opposite, this is adjacent. So it's always hypotenuse first, and you choose, depends on what angle, you choose the sine or cosine theta to find the line length, right, of the triangle. So then if we come back here, right, vectors magnitude is a length, which is a hypotenuse, right? So hypotenuse is given, and then angle is given. So you can find the AX, this line, AY, this line. Again, this is because we use a theta here. This is a adjacent, so it's a cosine. This is opposite, so it's a sine. And then, of course, now another thing is if we know sine, right, theta, we can also find the angle as well, right, using the tangent inverse. So in other words, there are two ways, right? In general, you can have a vector in terms of ax comma ay, right? And then you can also express the same vector in terms of r, which is hypotenuse. So I can say this is a, the variable we use, the magnitude of the vector a, and theta, right? So then you can move from here to here easily. How? if you know AX, AY, what does that mean? You know this length, AX, and this length, AY. So then how can you find the A, which is the length of this? That's simply root AX squared plus AY squared. So if you know this, you can find A easily. And then how can you find the angle theta? Theta is nothing but tangent to inverse function, right? So tangent theta is what? A y over ax, right? So then theta is what? Tan inverse ax over ax. Sorry, this is ay, right? So then basically, if you know this information, you can find the an theta, right? And then our second question is, what if you know a theta and how can you find the ax and ay? That's exactly what we did, right? So if you know a and theta, that means that this is a, this is a theta, right? And then how do you find the ax and ay, which is this and this, right? And then this is again hypotenuse times adjacent, so it's a cosine theta. This is hypotenuse times opposite, so sine theta. So basically you can move back and forth, right? Whenever you need it, right? So this is again how you convert xy, ax, ay information to an theta information, right? So what is the component of this vector question? Simple, right? X component is a 1, 2. Y component is a 1, 2, 3, right? So it's a 2, 3. Very simple question. And then what is the component again? I think now you guys can do it quickly. X is a 3, Y is a -4. Sir, right? And this one again, we're now looking for the final position here, which is a -3, 1. We are not interested in here, right? We are always interested in this vector 1, 2, 3, 4, and then 1, 2, right? So the answer is D. And then this is again different vector, right? Magnitude is given and the angle is given this time, right? So then now that means this is you can decompose, this is a cx, this is a cy, right? Or in this triangle, you can also say this is a cx, this is a cy, right? So if you think about, think of this triangle, you can find the tangent inverse, which is the pi, is given by d, right? And then now we have a 4 unit. So 4 unit vector has a length of 4 unit. So that means that this length is a 4, right? So then again, same. We know the hypotenuse, we know the angle, right? So now we are looking for the x and y component. So then now you draw your triangle. So the thing is, you can either use this right triangle or you can also use this right triangle, but doesn't matter. Why? Because anyway, you're looking for this is a AX, which is the same as this length. And then this is your AY, same as a AY. So basically, you can either use this triangle to find this, or you can use the other triangle to find this, right? These two lengths, right? But now let's use the first triangle, for example. So then now you are looking for AX. So now we are interested in the magnitude only, right? So the hypotenuse, the problem said the hypotenuse was a 4, right? So this is a 4, right? So always hypotenuse first. And then this length is the opposite to this angle, right? It's opposite. So this is opposite is a sine 30. And then AY is 4 times cosine 30, right? But you see x is moving to the left, so you gotta have a minus sign, and then y is going up, so it's a plus sign, right? So the answer you see is a B. And then similar question over and over. Again, unit is a 4. And then you can draw any random. You can draw one of, this random right triangle. Again, you can either use this one or the other one, doesn't matter. But anyway, for both cases, what you're looking for is this is a AX, this is a AY, right? Again, this is a adjacent, so it's a hypotenuse times a adjacent cosine 30. This is a opposite to the angle, so this is a 4 times a sine 30. But again, x position negative, y position negative, so they both have a negative signs, right? So the answer is a E. I highly recommend you to solve this very, very, very carefully, okay? And again, the similar question, we have an acceleration vector. So basically, it doesn't matter which type of a vector you have. It can be acceleration, it can be velocity, it can be displacement, it can be force. Any type of vector, doesn't matter. You gotta use the same method to find the component of each vector. So again, magnitude 6, angle 30. So you can either use this triangle or you can use the other triangle. But now let's use this triangle. So your hypotenuse is a 6, and then this one is adjacent to the angle 30, right? So hypotenuse times adjacent cosine 30. This one, hypotenuse opposite to the angle, so it's a sine 30. And they both have a negative signs. Okay? That's the answer. Okay? Well, your answer is here. And now you can add. So this is actually, so far what we did is how to add, right? How to find each vector's component, right? But now let's assume we are looking for, the addition of two vectors. So what we have done so far is, okay, we found a vector's x component and y component. And then you can also find the b vector's x component and y component as well, right? So that's what we did so far, right? But now question is, how do you add c vectors? How do you find the c vector, which is the addition of a and b vectors? So now let's assume this is your a vector. Again, a vector consists of two parts, right? Horizontal component and it's a vertical component. So in other words, a vector is simply a x vector 더하기 a y vector. And then b vector is also consists of two parts, right? Its own x vector and its own y vector, right? So the c vector, which is the addition of these vectors. So graphically, you know how to add these two vectors, right? Draw first vector and draw second vector. So your c vector, because the c vector itself is another vector, also has its own x component and y component called cx and cy. But what is the cx? Cx is nothing but ax and bx, right? The addition. And then cx is cy is what? Nothing but ay 더하기 plus a by, right? So your c vector's x component is simply a vector's x component, b vector's x component. And the c vector's y component is ay plus by. So if you have a more than, three vectors addition, you can simply, assuming you have a d vector plus a d vector here as well, then you can simply find the d vector's x component and d vector's y component, and then add ax, bx, dx. Then that's going to be your c vector's x component. And the y component of c vector is ay, by, dy. You can add them all. So if you have more than three vectors, for example, f vector is a random vector, is the sum of n vector, w vector, small f vector. So that means each of these vector has their own component. For example, n vector has a nx and y. W vector is a wx and wy. Small f vector is a fx, fy. So if you're looking for f vectors, x component, you can simply add nx, wx, fx. So today's lecture is again extremely important, like last lecture as well. So make sure you know how to add the vectors. So basically what we did is you can express a vectors in terms of r comma theta. R hypotenuse, theta is the angle. You can express the same vector as what? A x comma a y, their component, right? And then how to add more than three vectors? If you want to add a c vector, if you're looking for c vector, which is a vector plus b vector plus d vector, whatever, your cx vector is what? A x vector plus a bx vector, add all x vectors, and then cy vector is adding all y component of the other vectors. Thank you. And then because this is online lectures, I think we should have a take-home exam. Okay, so I'll assign your take-home exam this weekend so that you can submit it by the end of this weekend as well. Maybe or sometime Monday. I don't know, but I will upload. Let me think about it. I will upload your exam on Friday morning, and then that should be due uh, Friday night. Okay, so you must submit it before Friday night. There's no excuse unless you let me know earlier. Okay, so make sure you will have a exam, take home exam on. I will publish it on Friday morning, and then you have to submit it by Friday night. Okay, you have to print out the exam, and then you have to write down everything, including all small steps. You must to show every single steps for your exam to get partial credit. If you just send me the numbers only, you're not gonna get the credit. Okay, thank you.